Good morning all. So this is the model question paper set 2 of engineering visualization subject. So we are going to solve the first problem from module 1. It is projection of lines. The end projectors of line PQ are 80 mm apart. NP is 16 mm in front of EQ and 60 mm above HP. While Q is 50 in front of EQ, 10 mm above HP. So first I am going to draw this XY line by taking thickness of 0.25 mm. Write XY VPHP because we know that it is lying in the first quadrant. So from the projection of lines we consider only first quadrant. And P is 15 mm in front of VP and 60 mm above HP. So we consider the locus line using offset command. Type 15, click enter. The same way here 60 mm above HP, select XY and give 60, enter. Okay, two lines we have drawn. And same way while Q is 50 mm in front of PP and 10 mm above HP. So give the distance 50 mm here. Okay. Now 10 mm above HP. Okay. So we have drawn all the locus lines now, and you can see the distance between the end projectors given for the line PQ. It is 80 mm apart. 80. First I will take a reference line for the end point P. Okay. Alright, this is P and this is P dash. So now horizontally we have to consider a distance of 80 mm from this end point. Enter 80. I'm selecting the end point. Okay. This is what P and P dash, and this is Q dash, and this is Q. Okay, so by joining PQ and P dash Q dash, okay, we get the upper end length in front V, upper end length in top V. Okay, so measure the dimensions. Okay, now using this upper end length, we can get the true length. Okay, just by rotating this upper end length and projecting downward, we get the true length. So take P dash Q dash length and cut the arc and then project downward. So here we get the true length. Join it with the thin line. This is what PQ2, true length in top view. Same way, so I'll be rotating PQ. Okay, then project upward. Not till here, only the first locus line we have to project it. Yes, from there you can join. It is true length, and you can see that both the true lengths are same length, so that indicates our problem is correct. Okay. As you know, the point R is located at a distance of 31 mm from P. So the distance between the projectors of P and R given 31 mm. Okay, it is 31 mm, and the point R is 70 mm front of EP. So that is, if given the distance of 70 mm, we'll be considering that 70 mm distance here for putting a point. So that is what 31 mm. From the XY line, we have to draw vertically downward length of 70 mm, and here exactly at this end point of 70 mm, so we have to put a point of thickness 2 mm. Okay, that is your point R. This is what your top view, and the front view, it is lying above XY line. We don't know at what distance. Okay, we will be proceeding with the question. You can see now we have to draw a perpendicular line from R on PQ line. So we have to draw that. We'll be drawing the same thing. So what it is given in the question. So actually this question, it's not there in the solution book. So it is somewhat like combination of your line and point problem. Okay. As per the question, I am doing it 90 degree. Okay. So you can subscribe for the channel, hit on the bell icon for the latest notifications, and share it to the maximum students so that they can be benefited from this. You can show the dimensions. Okay. Just by projecting upward, so till it touches the upper end length, I will extend it, and I will be writing the R dash. Okay. So that completes the problem. Okay, now we will go to the second problem, that is solids problem. The square pyramid, 50 mm side base and 50 mm length of axis is resting on its triangular face on the HP with the slant edge. Okay, first I will be constructing XY line. So the thickness of XY line is 0.25 mm. Here square of dimension 50 constructed with the slant triangular face. Slant triangular face means edge we have to consider. Go to rectangle by center, give the width 50 and height also 50. So we will get a square. Now since it is a pyramid, we have to draw the slant edges, thick lines we have to draw. Show the dimensions on one side. So now you can write on the naming of it. Okay, now for the front view. In the front view, the axis length is 50 mm. Actually, this problem also not there in the solution book. Okay. So as per the request of the students, I am solving this model question papers. So make use of it and share it to the maximum students so that they can be benefited from this. The front view of a pyramid is a triangle. So measure the axis length. Write on notation. So P dash visible but A dash not visible. Similarly, C dash visible, D dash not visible, O1 dash not visible, and O dash visible. Okay. Now with respect to the slant triangular face, we have to make sure resting on the HV plane. Means we have to take this slant triangular face C dash, D dash, O dash and resting on the XY line. So go to move command, create a copy of it, slide along the line. Now select C dash, D dash and O dash edge and then rotate. And touching on the XY line. Okay. Now project it downward to complete the second position, top view. Draw the projection lines. So draw by zooming in, okay, so that you can draw it from the exact ends. And make sure you're joining to the correct endpoints, okay. Mention the names. Properly see it because it is already placed with the slant triangular face. You see the exact namings and write down correctly. Okay. Okay, now we construct the outer boundary line. That's what the first step. Okay. Now the square face, it is visible from the top view. That is why continuous line, and the dashed line, it is for the slant triangular face C dash, O dash and D dash, written with the dashed line. Okay. Now there is an axis from O1 to O. Okay. So the extra lines I am going to erase it using trim command. You can see the edge which is now here, we have to make that parallel to the VP. So parallel means we should consider the CD end and then we have to rotate it and make it parallel to the XY line. So by taking this CD line here, we have to make this CD, now it is parallel to HP, so we want to make it is parallel to VP. So by taking this CD line, we'll make it parallel to the VP, rotate it. So like this you can place. So now you see the end CD, the resting edge, now it is parallel to the VP. Okay, so that's what here in this problem he has not given angle of inclination to VP. Instead of that, he is telling we have to make the resting edge CD parallel to the VP. Okay, now project it upward to complete the final position. So draw the projection lines. Now write the names. Okay, first I will construct the square base here. It is I will construct first this A dash, B dash, C dash, D dash, and the straight line. Now I will be constructing the slant edges. Okay, so this completes the problem. Okay, now we complete the problem number 3. That is this problem given it is isometric. Okay, so write regular cone of base diameter 40 and height 60 is placed coaxially on top of a regular hexagonal prism of base side 30 and height also out of the axis 60. That means first I should construct this hexagon. That is first I have to draw the orthographic top view. So remember it, for the polygons such as triangle, pentagon and hexagon, we should always construct the orthographic top view because you require box dimensions in order to construct it. Okay, change the dimension to 30. Now using this box dimension, okay, we have constructed the box. I have to show the box dimensions. Okay, so for the hexagon box with the box dimensions constructed, now I'll be constructing the orthographic of it. Take a reference line. Okay, so from this reference line, so construct a box for a length of 51.96. that is what the first length, 96, and angle 30 degree. Okay, the second length is 60, angle is 150. Again the length is 51.96, angle is 210. Okay, now join. So box it is constructed. Now we have to cut the arcs. Okay, for a length of 51.96, we will be cutting an arc of 25.98. Take the radius and cut the arc. The same way, in the opposite side also, I will be cutting for the same arc length. Okay, that is 25.98. Give the radius of 25.98 and cut the arc. for that other edges we have to cut a arc length of 15 mm from the corner ends. Okay, 15 mm. From this side also 15. Cut it. Same way from here also. Cut it for 15 mm. Same way you can do it here. Radius of 15. Okay, now go to thick line. Now connect all these points. Okay, that's complete the bottom of the hexagon. Now we have to consider a vertical height of 30 mm. You can see 30 mm length of the axis. So height should be 30. First I will draw the vertical line from one reference end 30. Okay. We go to move command. It's a copy. Select the corner end and then place it with respect to all the corner points. Okay. By using continuous line, I want to join all these corner points. Okay, so that completes the hexagon. Now exactly at the center of it we have to place the cone here. Okay, so to place the cone here separately, what I'll do, I'll be constructing the hemisphere, that is ellipse of dimension 40 separately. You can see a right regular cone on base side 40 mm. Okay, on one side I'll be constructing by taking length. The length will be 40, angle is 30, and again length is 40, angle is 150, length is 40, angle is 210. Join it. Go to lines, select it, make these lines as thin. Okay, now go to again line. Using 4 arc by center method, construct the ellipse. We all know how to construct the ellipse. Cut the arc, taking the first length as a reference. Third point is your reference point, and cut the arc. Same way for the fourth point. Okay, after constructing the ellipse, I'll make the ellipse as thick here, thick line. Okay. Now I'll be drawing the two lines to find out the center. Okay, the same case I'm going to do it in the hexagonal prism also. So getting the center point now. By selecting the center point of the cone, ellipse. Okay, I'm going to place exactly on the center of this. Hexagonal prism. Okay, select exactly the center point. so that you're going to place it exactly in the center point. So, and again I'm going to do it. So select the ellipse here, select the center point. Okay, place it. So we have placed. Now the axis length we should consider, that is 60 mm. Okay, from the center of it. Now go to continuous line and draw tangential line for the ellipse. Okay. Okay, so that completes the isometric of it. Now we have to select the whole diagram and convert into isoscale. So go to scale here, and in the scale you give the value 0.816, enter. So it will be converted into ISO here. So just to measure the dimension, you can see the dimensions has been reduced. That means it indicates it has been converted into ISO scale. Okay, now we do the fourth problem, that is vertical chimney of circular cross section 400 mm diameter joins a roof sloping at 35 degree to the horizontal. The shortest portion of the chimney over the roof is 300 mm. You can see, so the question I have copied, and you can see in order to illustrate it, so I have written a small diagram to indicate chimney and roof, and there is a roof with an angle of 35 degree. Okay, here, so here the chimney, it is in the shape of your cylinder. Okay, so here the scale given 1:10. 10 means this 400 mm will be divided into 40 mm. So go to circle and take diameter 40. Okay, now divide this circle into 8 equal parts. For this I am using thin lines. So the angle you should consider, that is 45 degree, 45, 90, 135 and 180. And now using the extend to next, this 135 degree. So using this extend to next command, we would extend these lines. Okay, mention dimension it is 40 mm that. Okay, now mention the naming for this cylinder. Top view, it is having two faces, top face and bottom face. Top face A and bottom face written within bracket A1. Okay, A1, BB1, CG1, DT1. Same way you can write the notations here. And go over, okay, center of the axis of the cylinder. Now by projecting upward, we can construct the front view of it. So the front view of cylinder is a rectangular face. But we don't know how much is the front view distance. Randomly I'll consider a length. I'll be constructing the front view. Okay. Okay, here you can see the rooftop has been inclined at an angle of 35 degrees further to the horizontal. So I'll be giving an angle 150. You can check the angle. So 30-degree inclination. Okay. So draw the projection lines. Now consider this top face and it is cutted upper portion. So I'll be making it thick. Before that I'll be splitting that upper portion. Selecting that upper portion here, I'll make that upper part as thick here. Okay. Now write down the notations here. Cutted portion for the cut plane. 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Now you can see shortest portion of the chimney over the roof is 300 mm. So from this end I'll be considering 30 mm. 300 means 30, 1:10 scale. Okay. Then cut. Then bring it back. So this is what's actually the front view distance. So that upper portion I'm going to trim it. Okay. Okay, now so using parallel line method. Parallel line means here there are two lines are parallel. This line should be parallel to the X5. Okay. Since it is a cylinder, the total length we should consider that is pi d. Pi into d. Diameter it is 40 mm. So you can calculate the total length using calculator. Pi into d. So the total length you will get here it is. Use the offset command and give the length 125.6. That's what your pi d length. Enter, click. So that's the total pi d length. Now we have to divide this 125.6 into 8 equal parts. So divide using calculator. You'll get the length, the distance here. So the length you will get it is 15.7. Okay. And then split it up into 8 equal parts. Okay, now write down the notations with the capital letter on the development portion. So draw the projection lines. One should be there on the vertical edges of A and E. Okay. Then 2 it has to be there on B and 8 should be there on H. So you mention it in order to avoid the confusion. Now from 3 and 7, from 3 it is on the vertical line C and it should be extended till G, and this is your point 3 and 7. 4 and 6, 4 on D and 6 on F. This is your 4 and this is your 6. and this is 5. Now connect this 1 2 3 4 5 6 7 8 and 1 using curve command. Okay, use the curve command here because this is a cylinder. Join from 1 to 2. So use the thick line, that is 0.5 mm thick. So you can subscribe for the channel, hit on the like button and the bell icon for the latest notifications, and share it to maximum students so that they can be benefited from this. So that completes the problem.